Welcome to lesson 3. Today we'll be doing arithmetic sequences, also known as arithmetic progression, which we just write AP for short. So if you see something like arithmetic sequence, AP, arithmetic progression, it all means the same thing. So we'll be looking at what are they, and we'll be looking at another formula, the formula to find a certain term of a sequence which follows arithmetic progression, and you'll understand more as we go through it. We'll be doing the easier questions today, just the basics, and the harder stuff we will do in the next lesson. Alright, so what are arithmetic sequences? Let's look at the following sequence of numbers: 3, 5, 7, 9, 11. You can see, so what's the pattern? You can see it's going up by 2. And bro tip, from now on, every time you see an arithmetic sequence, I want you to think of it like this. The sequence starts at 3 and goes up or down by 2. Obviously, the numbers will be different depending on the sequence. The numbers might be going down. The important thing is they go up or they go down by the same amount. For example, let's look at a sequence where the numbers are going down. 10, 7, 4, 1, -2. Well, the sequence starts at 10 and goes down by 3. Every single number is 3 less than the previous term. And sequences like the ones above, these are the two that we've just done. In other words, sequences where the numbers are increasing or decreasing by a constant amount. They're always going up or they're always going down by the same amount every single time. And that is the pattern. And if this pattern is consistent throughout the entire sequence, we call this an arithmetic sequence or an arithmetic progression. So if the numbers are changing and they follow a pattern, and the pattern is such that they're going up or they're going down by the same amount, then we call it an arithmetic sequence. And I'll be using both arithmetic sequence and arithmetic progression just so you can get used to both of these terms. So remember, the definition of an arithmetic sequence is a sequence of numbers where each term is the sum of the previous number and some fixed constant. Okay, this fixed constant, in other words, the amount that is going up or going down by, it's fixed, it's the same, and we call this the common difference, or simply difference, of the arithmetic progression. So the amount that is going up or going down by, we call that the difference. Alright, moving on. Look at the sequence below. Small quiz. What type of sequence is it? We've just done it, so hopefully you should be able to do this. I do want you to pause the video and try to answer these questions. And I guess the question is, where's my mouse? There it is. Alright. So, what are these? What's this +3? What is that called? And that +3. What is it called? This is the sequence: 2, 5, 8, 11, 14. So what is the +3 called? And I guess the +3 is that from 2 to 5, it went up by 3. From 5 to 8, it went up by another 3. And it's going up by 3. So what type of sequence is it? And what is that 3 called? And the answer is that +3, if I can get it to work. Okay, I don't know why it did that. But anyway, it's called the common difference. And this sequence is an example of an arithmetic progression or an arithmetic sequence. Remember, an arithmetic sequence is one which has a common difference between terms. In other words, a sequence is arithmetic if adding a fixed constant to any term gives the next term. If we take 5 with +3 gives us, say, if I take 8 and +3, that'll give us the next term. I think I've said this enough. Hopefully you get the idea. Alright, so I guess small test. Which of the following are arithmetic sequences? I would like you to pause the video now and figure out which of those sequences are arithmetic. And if it is an arithmetic sequence, write the next 2 terms. Just pause the video now and give it a go. Alright, hopefully you've done them. Let's see if we can do them. The way I always do it is I look at these 2 terms and it went up by 2. So I'll just write +2 here. I'll just write +2. From 3 to 7 it went by +4. That is not an arithmetic sequence. A is not an arithmetic sequence because it went up by 2 and it went up by 4. It's different. It's going to go up or go down by the same amount. Alright, 2 to 4 it was +2. and then it became plus 3. 4 to 7 is plus 3. B is also not an arithmetic sequence. From 2 to 5 it is 3. 5 to 8 it is 3. 8 to 12 it is 4. That is not an arithmetic sequence either, because it went 3, 3, then 4. Okay. 6 to 3 it went down by 3, so negative 3, and it went down by negative 1.5. That is also not an arithmetic sequence. Okay, now looking at E, 7 to 4 it went down by 3, then it went down by another 3, went down by another 3. Hey, that is an arithmetic sequence. And let's write the next 3. So it'll be negative 5, then negative 8. Easy. Alright, 16 to 8 to 4, we can clearly tell, it's halving, it's not going down by the same amount. Went down by 8, went down by 4. That's wrong, that's not an arithmetic sequence. 1 went down, became a third, then became a ninth, became 1/27th. That is clearly not an arithmetic progression. Looking over here, negative 8 to negative 1, added 7. 1 to 6 is also adding of 7. And 7 plus 6 is 13, 7. That is an arithmetic sequence. So let's write the next two. 20, 27. Alright, lastly, half. That is also a half. 3/8. Yeah, no, that's not arithmetic progression. Alright, so hopefully you can see how we find arithmetic sequences. This is another quiz, I guess. Find the third term of the following arithmetic sequence. And I guess the idea that I want you guys get used to is it's going to go up or down by the same amount. 5 to negative 2, it went down by negative 7. So it's going to go down by another negative 7. So negative 9 will be the next term. 4 to 9, it was adding of 5. So 9 plus 4 is 13. Wait, 9 plus 5. Oops. Hang on a second. Sorry about that. Whoops. Alright, so it went up by 5. So 9 plus 5 is 14. So we're supposed to add 5 there. Alright, so the difference between the third and second term will be the same as the difference between the second term and the first term. This is just a fancy way of, the algebraic way of writing exactly what we just did. Now, it's important that you get used to this formula. That the third term minus the second term is going to be equal to the second term minus the first term. So 14 minus 9 is going to be 5. That has to be equal to 9 minus 4, which is 5. And I know it looks like a complicated thing to do. Why would we do it? It's just so easy to do just the way we did it. Why would we do it this way? And the answer, I guess, is when we get to, whoops. Alright, the answer is some of the harder questions will require us to use this formula. You do need to know it, you do need to get used to it. This is how we check if an arithmetic sequence is actually an arithmetic sequence. Otherwise, sometimes it's not so easy to see. For example, look at this one. Is that an arithmetic sequence? Check. I would like you to pause the video and check, and this one as well. Are these arithmetic sequences? And so far we've only done easy ones. These are slightly harder. And how will we check? Well, we use the formula, right? And at first sight, the above don't seem to be arithmetic progressions, but they are. And how do we know? How do we check? Well, we use the common difference formula. T3 minus T2 is equal to T2 minus T1. We check by saying, okay, let's look at this one first. 3x plus 5 minus 2x plus 3. What does that give us? Well, it gives us x plus 2. You can figure it out and check for yourself. And 2x plus 3 minus x plus 1 also gives us x plus 2. So there is a common difference between these terms. Therefore, it's an arithmetic sequence. Similarly, over here, square root of 2 and square root of 8. Well, square root of 8 is square root of 4 times 2, which is 2 root 2. Right? 2 root 2 minus root 2 gives us a difference of root 2. And that is 3 root 2. Because 9 times 2 is 18. The square root of 9 is 3. If you're not quite sure, just go and revise surds. You do need to be, really good with surds, I guess. It's a basic skill. You just need to have it. Anyway, the point is, we do square root of 18 minus square root of 8, and we check, is that equal to square root of 8 minus square root of 2? Is there a common difference? And we'll find that yes, there actually is a common difference, and therefore that is an arithmetic progression. The point is, arithmetic sequences always have a common difference. That's just such a basic fundamental idea you really need to understand at a fundamental level. Arithmetic sequences have a common difference between terms. And we can use this fact to figure out an algebraic formula for arithmetic sequences. Alright, so we're going to derive the formula. Let's say if you're given a sequence, 2 plus 5 plus 8 plus blah 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 plus n, right? Find what would be the 150th term. Now it's an arduous question, right? It's a hassle to just write down every single term 150 times. However, there's a formula we can use, and right now in this slide we are going to figure out what that formula is. We're going to try and find a pattern and figure out the formula. Okay, so what is the first term? Let's say if you have a random arithmetic regression, right? And the first term is A. The first term is A, and the next term is going to go up by D, right? It's going to go up by D. So what is the first term? Well, the first term is A. They told us so. What is the second term? A plus D, right? The second term will have A plus D, one difference added on. And what is the third term? Well, a third term will be A plus D, which was the second term, plus another D. And we can just simply write this as A plus 2D, because D plus D is 2. So A plus 2D. Now I want you to note that the third term has 2D. The fourth term will be A plus 2D plus D, which is A plus 3D. The fourth term has 3D. So my question is, what is the relationship between the position of the term and the coefficient of D? So if it's the fourth term, what will be the number next to D? Try and figure out a pattern, and pause the video if you need to figure out a pattern. The answer is quite simple. The coefficient of D is 1 less than the term number. So what would the nth term be? If I asked you to find the nth term, it'd be A plus n minus 1D. N minus 1D. It starts at A and goes up or down by D. That's why I wanted you to get used to thinking of it like that. The A, so we need two things basically for any arithmetic sequence. To describe an arithmetic sequence, or to find the nth term of any arithmetic sequence, we need two things. We need the number it starts with and the difference. If we have these two, we can figure out any number in that sequence, any term in that sequence. Okay, so quick revision. Formula for the nth term in AP. We use A to denote the first term, D is the difference between terms. What will the first term be? And I do want you to pause and just revise. This is kind of like a recap of the previous slide. We're just doing it twice, just so just to check that you guys understand. So first term is going to be A. Second term is going to be A plus D. The third term is A plus 2D. Therefore the nth term is going to be A plus n minus 1D. So the nth term of an arithmetic sequence, to find a certain term, is just A plus n minus 1D. So if we wanted to find, for example, the second term, T2, we just substitute 2 for n. So A plus 2 minus 1, which is 1D. A plus D will give you the second term. If you had to find the 100th term, you would say T100 is equal to A plus 100 minus 1D, 99D, right? So let's look at a few questions. So example 1, the nth term of an arithmetic sequence is T of n is equal to 55 minus 2n. This will give us the nth term. Write down the first 3 terms of the sequence. So we're just going to sub in n is equal to 1, n is equal to 2, n is equal to 3. Write down the answer, and 55 minus 2 is 53. We'll start off at 53, 51, 49. Okay, it's just subbing it in. Very easy. Find the first term of the sequence that is negative. Or we'll let 55 minus 2n, we'll make that less than 0, and we'll solve the inequality. Less than 0, and solve simple algebra. N is going to be more than 27.5, therefore n will be 28. The 28th term will be less than 0, and we can check. And if we sub in 28, we'll find, yes, it's negative 1. Okay, it just became 0. And similarly, another example, find the nth term of each arithmetic sequence. So we have to find the nth term. Basically, we have to find T of n. We have to find the formula. Well, 6, 20, 34, 48, 62. The first thing we do, we know A, 6 and 101, right? And what is the difference? 14, 14, 14. So A 6, D is 14, T of n is therefore, we know what A is, and we know what D is. Just write it down, expand it, simplify it, 14n minus 8 will give us the answer. Similarly over here, A is 101, and it is going downwards, the difference will be negative, right? And how much is it going at? 6 and 1, 7. Negative 7. So D is negative 7. Subbing these values of A and D into that formula, simplify, expand, blah, 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 and you get that. Okay? So bro tip, always write out A is equal to something, D is equal to something. That's the first thing you should do when you are dealing with the nth term of an arithmetic sequence. Just write that down, it makes it a lot easier, it'll save you from making silly mistakes. Okay, so another question. Consider the sequence 2, 9, 16, 23, 30, and so on. So this is kind of like what would appear in a trial exam or the HSC exam. This is a typical question. An easier question, yes, but it is, you know, a typical question. Show that the sequence is arithmetic. You need to know the common difference formula. The difference between each of these terms is the same. It happens to be 7. 9 minus 2 is 7, 16 minus 9 is 7, 23 minus 16 is 7, and so on and so forth. So the sequence is definitely arithmetic. Find the formula for the general term T of n. Well, we know A, we know the difference. If we know A and the difference, we can simply write it down. So that, expand, simplify, blah, easy. Find the 100th term of the sequence. Well, we have T of n, 7n minus 5. We sub in 100, 7 times 100 minus 5. 695. 7 times 100 is 700. Minus 5 is 695. Easy. Is 828 a term of the sequence? Well, we'll let 828 equal to T of n, and we'll see if it works. So 7n minus 5 equals to 828. Will that give us an integer solution? Now the idea here is n has to be a whole number. It has to be 1, 2, 3, 4 or something. And it has to be positive as well. And the reason for that is you can't have a term, you can't have the 1.5th term. It doesn't make sense. It'll either be the first term or the second term or the third term. There's no such thing as the 3.5th term. It doesn't make sense. So n has to be a positive whole number. And that's how we will check. We'll try and solve this algebraically, and we check, well, is n an integer solution? And it is. It's 119. So therefore, 828 is a term of the sequence. Similarly, 2, 3, 4, 1, is that a term of the sequence? And sub it in, and we find out no, it is not. Does not give us a whole number. If we solve that algebraic, we find that n is equal to 335 and 1/7. Therefore, that doesn't make sense, right? So therefore, it is not a term of the sequence. All right, another question: how many terms are there in the sequence 3, 7, 11, blah 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 to 919? We know A, we know D. We just have to solve for n. Okay, now these numbers form an AP. Let's figure out the values of A and D. A is 3, the difference between them is 4, right? And now we can just write out the formula, and we're going to solve for n. Now we know the nth term is 119. We just need to find out what n is, right? So with 119 is equal to 3 plus 4, n minus 1. Algebraically solve it, and easy. Therefore, 119 is the 30th term of the sequence, which means there are 30 terms. Now, this is another HSC question. I have not done the solution for this. I want you to give it a go yourself. It's very similar to what we just did here. Almost exactly the same, just different numbers. Give it a go. It is a HSC question from 2014, question 12D. It's the first part of the question. We haven't done the rest of this topic, so obviously we can't do the whole question, but this is the first part. You should be able to do it. Okay, and that's it, and best of luck with the homework.